Chapter 8, Theories and Research on Operant Conditioning. The role of the reinforcer. The previous video reviewed some evidence that operant conditioning can occur in the absence of an operant response. Rats were able to learn where to find food reinforcement in a maze when they were carried through it passively rather than exploring it themselves. In this video, we'll examine whether reinforcement is necessary for operant conditioning to occur, or more precisely, whether the delivery of a consequence is necessary to modify a voluntary or non-reflexive response. Together with his colleague Hanzig, Tolman developed another maze experiment to test whether learning could occur without differential consequences, that is, reinforcers, for behavior. Tolman and Hanzig used a 14-arm maze. This experimental apparatus is similar to a T-maze with two key differences. First, the rat is usually placed in the middle of the maze at the start of a trial, so the choice point occurs right away rather than after it runs down a runway. And second, there are 14 arms that the rat could choose to take instead of just 2. Tolman and Hanzig conducted an experiment in which they designated one of the 14 arms in the maze the goal arm. They put rats in this maze once per day for 17 days and recorded how many arms each rat visited before they reached the goal arm. They called this the number of errors the rat made, and that's the dependent variable in this experiment. They also divided the rats into groups. For rats in Group 1, the goal arm contained food on all 17 trials. The behavior of Group 1 rats was regularly reinforced. Specifically, the operant response of visiting the goal arm was reinforced with food every day. For rats in Group 2, there was never any food anywhere in the maze. So Group 2 was the no food reinforcement group. Lastly, for rats in Group 3, there was no food reinforcement for the first 10 days of the experiment. But starting on day 11, the goal arm contained food. In other words, for Group 3, the operant response visiting the goal arm was reinforced with food on days 11 to 17 and not before. So the independent variable in this experiment is the different food reinforcement circumstances for the 3 groups: regular reinforcement, no food reinforcement, and no food reinforcement until day 11. Tolman and Hanzig recorded the number of errors rats made each day, how many empty arms they explored before finding the goal arm. Remember, the goal arm was the one with the food if reinforcement was provided, but otherwise there wasn't anything special about it. Tolman and Hanzig graphed the average errors per day for each group. What do you think the graph looks like for Group 1? That's the group that got food from the very beginning. How about for Group 2 that never got food in the maze? Which group of those two would have made more errors, that is, visited more arms before reaching the goal arm, Group 1 or Group 2? Finally, what do you think the graph would look like for Group 3? Pause the video here to make your guesses, then continue watching to see the results. At first, it took Group 1 rats a while to find the goal arm with the food in it. But as visiting the goal arm was reinforced with food, on average, Group 1 rats got there a little faster every day. This is consistent with what we should see if reinforcement is necessary for operant learning to occur. Group 2 never received food reinforcement, and they never really got very good at going directly to the goal arm. Their behavior didn't change very much. When we compare Groups 1 and 2, it's clear that Group 2 made more quote-unquote errors than Group 1. By the end of the experiment, or even by day 10 or 11, Group 1 rats got to the goal arm much quicker or more directly than rats in Group 2. They were only making 2 or 3 errors. They were only visiting 2 or 3 arms before they went to the goal arm. Whereas rats in Group 2 were visiting 6 or even 7. So far, this is what we'd expect to see if reinforcement is necessary for operant learning. But let's talk about Group 3. The experimental conditions for Group 2 and Group 3 are identical for the first 10 days of the experiment. So on average, Group 3 should make about the same number of errors as Group 2 for those days. If they don't, it's for some reason that's not related to the independent variable of this experiment because there's no difference between those two groups for those days. But on day 11, visiting the goal arm is reinforced with food just like it has been for Group 1 rats all along. In other words, if reinforcement is necessary to learn a voluntary response, day 11 for Group 3 should be just like day 1 for Group 1, which means we should start to see the same steady decline in number of errors just starting 10 days later. So what actually happened with Group 3? The first 10 days went just as predicted. Group 2 and Group 3 rats made just about the same number of errors. So what happened on day 11? Well, instead of a steady decline in the number of errors like we got with Group 1, there was a very sudden drop in errors. For each day after day 11, Group 3 was even faster than Group 1 at getting to the goal arm. So what do these Group 3 results mean? Well, Tolman and Hanzig figured that Group 3, as well as Group 2 rats, were learning about the maze the whole time, but that learning was latent, meaning it was hidden. It didn't immediately have an observable effect on behavior. After all, if there's no food in the goal arm, what's the rush to get there? Their conclusion was that reinforcement is not necessary for the learning of a new response, but it is necessary for the performance of a new response.